Alright, what is up, Internet? We're going to talk about some trig reciprocal functions today. So, to begin, let's talk about what the heck these things are. So, if you have sine theta, cosine theta, and tangent theta, these are your basic trig ratios that we've dealt with for quite a while now. Now, we have some other ones that we've talked about as well, which are cosecant, secant, and cotangent. So, definition-wise, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent, which is really cosine over sine, or you could call that 1 over tangent. They're kind of the same idea there. And then back over here, they are just reciprocals of each other, so you can go kind of back and forth and look at these this way as well. So we have cosine is 1 over the secant, sine is 1 over the cosecant. All right, so there's definition-wise, that is what we're dealing with on the trig reciprocal functions. So moving on into some examples here. So I could give you a triangle, and this is off of a worksheet that I gave my class here, but it would ask you to find a certain trig ratio. So it'll say find cosecant of theta if we have a triangle that looks like this. We have 9, we have 6 root 2, and we have theta. Okay? So what we have here, we're dealing with cosecant. So I know that cosecant would be 1 over the sine. So that's something we'll have to know as we work these problems. So one way I could do this is I know that sine of theta is opposite over hypotenuse, right? So then cosecant of theta would then be hypotenuse over opposite. So let's try and see if we can label the sides of this triangle. I know hypotenuse is 9, it's across from the right angle. Adjacent is next to my angle, and opposite is across from the angle. So it looks like we're actually missing the opposite, which is what we need to find the cosecant, because it's hypotenuse over opposite. So we'll be using the Pythagorean theorem to find, we'll label it as an x here, okay? So x squared plus 6 root 2 squared equals 9 squared. We're going to be solving for x. That will be my opposite side, okay? So x squared plus 6 root 2 squared should be 72, and then 9 squared is an 81. So then x would follow to be equal to, or x squared to be equal to 9, so x is equal to a 3. All right, so we found the missing side we needed. So then cosecant of this angle will end up being the hypotenuse, which is 9, over the opposite, which is 3. So really my answer is just a 3 there. And that's my final answer. So that's kind of the process, if you will. If you're given a triangle, try to figure out what side ratio you might need. And as a kind of a recap to make sure we're on the same page for all of these, it might be nice to mention the SOHCAHTOA to make sure that we know our sine, cosine, and tangent ratios. So that's kind of a recap back to geometry somewhere, talking about trigonometry for the first time there. But moving on into some more difficult problems. Let's look at another example. So for my class, for Mr. Self's class, number 9, it says find cosecant if secant equals root 5 over 2. Put an equal sign here. Okay, so what I like to do here is I like to tell a story. So I say there once was a triangle with an angle theta, whose secant is root 5 over 2. Now remember, cosine is adjacent over hypotenuse. That means that secant is hypotenuse over adjacent. So we can label our triangle here. So if my hypotenuse is root 5, then I know this is root 5. My adjacent is 2, so I have 2 there. Okay, now it's asking for cosecant, and I know that cosecant of theta should be hypotenuse over opposite. So I need to find out what this opposite side is again. So Pythagorean theorem, 2 squared plus x squared equals root 5 squared. So we have 4 plus x squared equals 5, and then x squared equals 1, so x is 1. So now, to wrap up this problem, cosecant of theta is hypotenuse, which is root 5, over the opposite, which is 1. So the cosecant of theta is just root 5. That would be my final answer on this problem. So I'm going to zoom ahead and do another example or two from this page in my class. Alright, so let's look at one where we're given an angle in standard form. And let's see if I should have room to do it here. So number 18, it says find secant theta, and it gives you a picture like this. It gives you this little angle drawn like so, where we have a rotation counterclockwise of 5 pi over 3. So I didn't draw this to scale very well, but let me back up here and help you guys out here. So knowing the unit circle, the angle that they've given us is in the fourth quadrant. So in the fourth quadrant of the unit circle, all these angles on the sheet for my class are on the unit circle. So we can, pick what quadrant we are and pick out the correct location. So what we have here is 5 pi over 3 is going to fall right here. So this is the angle we're given. Now, in my class, we talked a lot about doing these things by hand. So the ordered pair here would be 1/2 negative root 3 over 2. And the way that I showed this to everybody is that we have a short leg on the x and a long leg on the y. And we know that a short leg is always equal to 1/2, plus or minus 1/2, and a long leg is always equal to plus or minus root 3 over 2 for the unit circle. So that helps us find out what the ratio is, or what the ratios are here. So remember, cosine goes along with the x, sine goes along with the y. So now secant is going to be 1 over cosine. So essentially secant of 5 pi over 3 will be cosine flipped over. So this is 2 over 1. So my answer here is just going to be a 2. Now, to extend this example a little bit, let's say that we are working and asking for cosecant of 5 pi over 3. So cosecant of 5 pi over 3 would be negative 2 over root 3. Now the problem here is we cannot divide by an irrational number of root 3, so we need to multiply the top and bottom of this fraction by root 3. So my final answer here would be negative 2 root 3 over 3. So if you're given one where you end up with a radical on the bottom, we have to fix that thing up. We have to rationalize the denominator. So that is kind of my goal of that problem. All right, so let's see about another example. I think there's a few more I wanted to do. Yes, so let's look at, for my class, number 24. So number 24 says cotangent of theta, and it gives us a picture again where we're given an angle and an ordered pair of negative 2 root 3. Now I'm going to extend this a little bit larger so I can label some sides, make it look a little bit better for us here. Alright, there we go. So what we have here are the x and y components of a triangle, or the two legs of a right triangle. Now if I labeled this as it's given, I would have x and y measurements like that. So now I know that tangent of theta is opposite over adjacent, and cotangent of theta is adjacent over opposite. So here, if I wanted to label these sides, my angle we're referring to is right here, so my opposite is on the y, my adjacent is on the x. So adjacent is 2, opposite is negative 2 root 3. So now we have to fix this up a little bit. We can reduce the 2's, so we're left with negative 1 over root 3, and then again we need to rationalize that denominator. So we multiply top and bottom by that irrational number, and we end up with negative root 3 over 3. And some of these, like if you're given this, you might be asked for cosecant or secant, then you would have to worry about finding the hypotenuse measure. So that's something that we've talked about already in here. So if we had another question that was asking for secant or cosecant, then you can go that route. But that is all we need to worry about for now. So thank you guys for listening.